Here we have tables that represent quadratic functions, and we can tell they're quadratic if the second difference is the same. As we look at this first table, the difference between 6 and 15 is 9. Let's see, 5 and 8 would be 13. Let's see, 15 plus 2, 17. Looks like we're adding 4 more each time. Okay, so this tells us it is definitely quadratic because the second differences are the same. The difference between 6 and 15 is 9. From 15 to 28 is 13. From 28 to 45 is 17. And from 45 to 66 would be an addition of 21. And each of the first differences have a common difference of 4. Because the second differences are the same, that identifies this as a quadratic function. To get the recursive formula, f of x equals f of x minus 1 plus some linear component. The first part will always be the same for all recursive functions or all recursive formulas. This stands for the term I want is equal to the previous term plus some linear component, which will be of the form mx plus b, which we learned about in 8th and 9th grade. That's in slope-intercept form. In other words, the first differences here form a linear pattern, or a pattern that can be written in the form mx plus b, slope x plus the y-intercept. The slope is pretty easy to find. It's this second difference right here. So the mx plus b, the slope will always be the second difference. To get our b, all we need to do is go back to our first second difference. So continue the pattern going up. Okay, so we'll go back 4. There's the first second difference plus 1. So our recursive formula is f of x equals f of x minus 1 plus 4x plus 1. And we can test this to see if it's right by plugging in a certain value for x. Let's try plugging in 3. When I do f of 3, it'll equal f of 3 minus 1 plus 4 times 3 plus 1. F of 3 we can see is 28. 3 take away 1, f of 3 take away 1 will actually be f of 2, which we can see is 15. 4 times 3 is 12. So we have 27 plus 1 more makes 28. So we can verify that we have the right formula by just checking a point. The explicit formula, ax squared plus bx plus c, can be found if we get a from a is half the second difference, in this case the difference was 4, so half of 4 is 2. C is our 0 term, so I need to go back and finish filling in the table, follow the pattern back. Let's see, so I added 5 to something to get 6, so it must have been 1. 1 plus 5 is 6. C is 1. C is the 0 term. F of 0, that'll give us C. F of 1, we can see f of 1 here is 6. And then the a plus b plus c, a plus b plus c will equal f of 1, because when I plug in 1 for x, the result will be a times 1 plus b times 1 plus c. And when we multiply something by 1, it won't change. Therefore, we know a plus b plus c will equal f of 1. So here we have 2 plus 1, which is 3. So I'm going to need 3 more to make 6. Now we can write the explicit form. F of x equals 2x squared plus 3x plus 1. There's our explicit form and our recursive form.